This video is a request from a student with regards to improper fractions and mixed numbers. Now, what are improper fractions? They're fractions where the numerator is a greater number than the denominator. So if this was 5 and this was 2. A mixed number is something like this. We have a 3 out the front, which is the whole number. The numerator could be 4 and the denominator would be, say, 7. There would be a mixed number and there would be an improper fraction. Well, improper fraction makes it sound like it's wrong. Often an improper fraction is actually really useful, especially with gradients and with a lot of things when you're wanting to multiply fractions quickly. Improper fractions like that are really useful and much more useful than mixed numbers. But the question was, how do we convert between them? So first thing we're going to do is we're going to convert from improper fractions to mixed numbers. Whoa, what happened there? That was awful. Kind of a half of B and half of an M. Mixed numbers. Okay, so let's use the one that we had before, 5/2, and convert that into a mixed number. Okay, what we want to do is we want to find out how many times does 2 go into 5. And we could do it on the side here until we're really used to it. So 1 2 goes in once, 2 2s is 4, 3 2s is 6, so it doesn't go 3 times, it only goes 2 times. So the number of times that it goes in is 2. Now what's the remainder? So now we take this number here, 2 times 2, and we get 4. 1 minus that number, and we get 1. So if we wanted to really break this improper fraction into a mixed fraction, 2 is going to be the whole number, 1 over. Okay, so I'll go over it again. I'll rub all this stuff out. I'll go over it again. We'll rub out our question again. Right. We will draw a line. The 2 is going to stay as it is. So let's do a little algorithm. The denominator stays as it is. Okay. Second step is we want to find out how many times 2 goes into 5. Does 2 go into 5, or whatever the different numbers are? And in this case, if it goes in once, it's 2. If it goes in twice, it's 4. If it goes in 3 times, though, it would be 6. So it's only going to go in twice. Okay. This number becomes our whole number. And it's not the 4, it's the 2. It's the how many times does it go in that we really care about. So it's going to become 2 out the front there. And now for the third step, the remainder, shall I rub that out a bit? The remainder, goes in the numerator. So a quick way of working it out is going to be 2, this 2, times this 2 equals 4. 4 minus the original number up here, 5, is a -1, so it's going to be 1. We have 1 left over. Okay, work it out in your head. Does 2.5 equal 5/2? Yes, that does. Next question is we want to convert 7 over 3 into a mixed number. Well, 3 is going to go across. And now I have to work out how many times does 3 go into 7? Well, 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 9 is too many, so 2 is going to be our answer. So 2 here is going to go out the front. Now we have to work out the remainder. So 2 times 3 here, which is going to be this one here, is 6. 7 minus 6 is 1. So this little 2 times 3 equals 6 tells you everything you need to know in order to solve that. Let's do a few more. Next one is 9 over 4. Well, we're going to put the equal sign there, and we're going to leave a bit of a gap. We're going to put a new divisor sign and 4 there. Now we work out how many times does 4 go into 9. Well, 1 times 4 is, of course, 4. 2 times 4 is 8. 3 times 4 is 12. 12 is too much. So there is our key equation. 2 is out the front there. And 9 minus 8, the remainder is 1. Can we simplify it anymore? No, we can't. Let's do a few more. Practice makes perfect. Let's do 9 divided by 4. It's a weird looking line, so let's just make it a bit bigger. Okay, we're going to have the equal sign. It's a improper fraction. The numerator is greater than the denominator, so we have to do something with it. Leave a gap. We're going to leave that 4 there. Now let's check out 4 times tables. 1 times 4 is 4. 2 times 4 is 8. There might be a winner. 3 times 4 is 12. That's too much. So our winner is this. So 2 is going to come out the front. 8 minus 9 is 1. And we're done. Right, let's just keep on keeping on. Let's divide. Well, let's rewrite 11 over 5. We get the equal sign. We put 5 there. Now we need to work out how many times 5 goes into 11. So 1 times 5 is 5. 2 times 5 is 10. You should really know these. And 3 times 5 is 15. 15 is too many, so that goes. So 2 times 5 and 11 minus 10 is 1. 2 and 1/5. It's getting a little bit tougher now. 17 over 8. It's going to equal something over 8. Now we need our 8 times table. 1 times 8 is, of course, 8. 2 times 8 is 16, so that might be our winner. 3 times 8 is 24, so that's not our winner. Our winner is 2 times 8 is 16. So 2 times 8 is 16. 17 minus 16 is 1. And that's our answer for that one. Okay, what do we got now? 22 over 7. 22 over 7. We have the equals. We leave a gap. We put the 7 there. So if you know your 7 times tables, you'll know that 3 times 7 is 21. 4 times 7 is 24. Sorry, 4 times 8 is 24. So this is the number that we are looking for. So our answer is 3. 22 minus this 21 is 1. So our answer is, we're going to mush these up a bit better. 3 and 1/7. So far so good. Let's do a couple more and then we'll do things the other way around. 27 divided by 5. Okay, let's put 5 down the bottom here. And now we need to know our 5 times tables again. So 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. We're still not there. 4 times 5 is 20. 5 times 5, getting pretty close now, is 25. And 6 times 5 is 30, which is too much. This number here is greater than the 27, so that gets eliminated. So 5 comes out the top here, and 5 times 5 is 25. 27 minus 25 is 2. So our final answer is 5 and 2/5. And that's about as hard as they get, really. All right, let's get on to doing things the other way around. But just a little trick. If we wanted to know what the number was to begin with, we could do 11 divided by 5. And the answer is going to be 2 point something. That 2 there in front of the decimal point is going to be our whole number. So we could kind of cheat using these numbers. Let's go down a bit. 17 over divided by 8 is going to be 2 and a little bit more. So our 2 would go at the front there. 22 over 7, 22 divided by 7. We're going to get 3 point something, something, something. Actually, a number pretty close to pi. 22 over 7 is a rough, good estimation of pi. It's not exactly pi, but it's a nice guess. 3.1728. And 27 divided by 5 is going to give us 5 point something. So it's a good first guess. Okay, anyway, back to where we were. The algorithm to changing a mixed number into an improper fraction is this. It's going to be the number out the front, the whole number, times the denominator, adding to the numerator. Okay, so in this time, 1 times 2, so the 2 stays there. 1 times 2 is 2. 2 plus 1 is 3. Okay, let's do one a little bit harder. 2 and 3/4. 2 times 4 is 8. 8 plus 3 is 11. And the 4 stays as it is. Let's do a few more of these. 3 and 2/5. Well, the 5 is always going to stay there. 3 times 5 is 15. 15 plus 2 is 17. Okay. 4 and 1/3. We draw the line. We draw the 3. 4 times 3 is 12. 12 plus 1 is 13. Really, it's not that much harder than this to do these. Let's look at this one, but a little bit tougher now just because they're higher numbers. 6 and 7/8. Go along here, we put the 8. So 6 times 8 is 48. We can even do it to one side. Add the 7. So it's going to be 5, carry the 1, and the answer is 55. Okay, how about this one then? 7 3/10 is an improper fraction. Well, 7 times 10 is 70, but the 10 stays there. 70 plus 3 is 73. One more. 8 and 11/12. Youch. Well, do you know your 12 times tables? Well, 8 times 12 is 96. This stays over 12. So 96 plus 11 is going to be 107. So 107. Oh, 107. That's the wonkiest 7 ever. Do that again, actually. 107. So as long as you keep the pattern the same, if you want to go from improper fraction to proper fraction, this thing here is always going to stay the same here. And this, how many times this number goes into this number is going to be the number that goes out the front. For this one here, when we want to turn mixed fractions into improper fractions, if we imagine it's like A over B over C, it's going to be equal to everything over B times B plus C. And again, that's the worst B ever. Okay, so using that, if we did any fraction, so 10 and 3/8 into a proper fraction, the 8 is going to stay there, and 10 times 8 plus 3 is going to equal to 83/8 as an improper fraction. And that's about it, really.